After the passage of the famous Halley's Comet in 1986, the European Space Agency gained interest in further exploring these icy interstellar bodies. For over a decade, a plan was formulated to intercept a high-speed comet after over a 4 billion mile journey. The Rosetta was launched on March 2, 2004, and came into contact with comet 67P over 10 years later on August 6, 2014. It is currently rescheduled to return to Earth's orbit in September 2016 after the perihelion passage of the comet. The craft has ventured through multiple Earth orbits, gravity accelerations, and massive fields of obstacles before getting close enough to intercept comet 67P by deploying a small probe Philae to the surface.
Each of the planetary flybys required months of intense preparation. In particular, the flyby of Mars in February 2007 was a critical operation. The new mission trajectory to 67P Churyumov-Gerasimenko required that Rosetta fly past Mars at just 250 kilometers from the surface and spend 24 minutes in its shadow. In the past, missions to comets mostly consisted of rapid flybys. The Rosetta mission pioneered comet tracking, interception, and prolonged observation. This not only allows for immense data collection, but contextualizing all previous
During
reports.
its 10-year journey to comet 67P, the Rosetta satellite encountered 2 asteroids. This was key in the journey because it allowed the scientists and flight team to get valuable practice and experience with the new flight controls and equipment that they had never been able to test out before. And this really made it so that they were able to have more confidence and stability and control over the controls and equipment when it came time to intercept comet 67. The most difficult phase of the mission thus far has been that of the deep space hibernation, something that has not been explored much because of the involved risk. There was a 2-year period in which Rosetta was so far in the solar system that it was unable to be controlled and had to rely completely on untested solar panels that have been specially made for absorbing radiation and far out in space. In January 2014, the onboard computer rebooted itself and reestablished connection with the Earth, marking a significant milestone in the mission, and meaning that the Rosetta comet was that much closer to reaching its target.
The Rosetta satellite has 2 essential components: an orbiter that circles around comet 67P, and the lander that touches down on the surface of the comet. The lander contains all scientific equipment needed to do research on comet 67P, including the study of the surface and the nucleus of the comet. The orbiter is a box-shaped structure that measures 2.8 meters by 2.1 meters by 2 meters. All subsystems and payload equipment is mounted on the central structure with 1 solar panel extending from each side face of the box-shaped structure, measuring 14 meters in length with a combined area of 64 meters squared. The entire orbiter is built around a vertical thrust tube with a diameter of 1,194 millimeters. The tube contains 2 propellant tanks of equal size, one containing the fuel and the other the oxidizer. The total amount of propellant that was stored in the craft at launch amounts to roughly 1,670 kilograms. The satellite's takeoff weight limit was set at 3,000 kilograms due to launch capability of the propellant in the tube.
The Rosetta spacecraft can operate on less than 1,700 kilograms of fuel in a 10-year span. The reason why it is so efficient is because it goes into hibernation during its cruise phase, which means that most of the electrical systems are not active. For critical mission phases, backup units are on standby for continuous and uninterrupted operation to ensure maximum subsystem reliability. Instruments on board the orbiter include ultraviolet imaging, impact analyzers, dust analysis, thermal imaging, and electron sensors.